Right, good afternoon everyone, and thanks so much for coming in for the session. We had a quick preview this morning and it's some fantastic information. The bulk of the presentation is by the Kia team from the Wellingborough Prison Project, and they're going to tell a fantastic story of real integration of modern digital manufacturing and materials technologies. I'm going to cap it off with a bit of a talk about what we do at the NCC and some innovations there. Then there'll be a panel session when you'll have the opportunity to quiz us on details. So with no more ado, I'm going to pass over to John Hanscom from Kia, who's going to lead you through the project.
Afternoon all. I'm just going to set the scene for my colleagues to present and talk about the hard work that comes together. In the first instance, talk you through the prison, which is a 16,000 place prison based in Wellingborough, and it's on a platform design that will be then rolled out to build out 10,000 places across the country. It's a different prison to what's historically been built, in that it's a rehabilitative prison, and it's based around skills and reintegration of society, and its main focus and aim is to cut reoffending. To deliver the project, we pulled together a supply chain from across the country, maximising digital and off-site, and we're pleased to say we've got two key speakers from PCE who have integrated the precast for us, and from Master Abaloy, who have developed new windows and doors for the prison that we sub-assemble and then take to the precast factories to install. But there's a underlying purpose to everything we do, which is the drive of our clients, and this prison is 70% more efficient than the current stock, which is predominantly Victorian, and has barless windows, which is the first in the UK to do barless windows en masse, and encourages family engagement and smart buildings. Further ado, I'll hand on to Simon, who is our specialist integrator for our precast solution.
Good afternoon. So, I suppose just to give you a bit of an overview of our role as integrator, because it's not a familiar term in construction, but it is relatively familiar in the off-site world. So essentially we're taking the concept design defined by the client, the Ministry of Justice, and the architect and the design team. And what we're wanting to do is we're wanting to dismantle that design and turn it into a kit of parts. The kit of parts can then be manufactured away from the project, and then what we've got to try and do is then bring that kit of parts back together and assemble it on site. Now originally we were transitioning from a different design solution, so there was a piece of work to do around the re-coordination of that design, but essentially we're going to consider all of these points around the circle: program, sequence, digital, logistics, methodology, design management coordination, interface coordination, smart systems integration, supply chain management off-site, prefabrication or pre-assembly or both, cost, validation and continuous improvement to essentially develop a solution that can be made away from the project and assembled on site. Just a bit of an overview of the scope. We're not actually delivering all the project, but the scope that we are delivering, I would guess, represents circa 70% of the project. We have the entry visits building, which is in the top left-hand corner, which is a very bespoke structure. So most things are one-off within this building, so a little bit unusual and off-site, but delivered using a hybrid type methodology, combining precast concrete with structural steel work with in situ concrete, essentially to give a fast-track construction solution to quite a complex building. We've got the CASU, which stands for Care and Separation Unit, which is a specialist accommodation unit up at the top of the site. But then the main crux of what we're delivering is the house blocks, the accommodation blocks. So we've got 7 of these blocks, which are identical, running down the bottom of the site there. So just to give it a bit of scale, the entry building's about 7,000 square metres. The care and separation unit's about 1,200 square metres. And then the house blocks represent about 50,000 square metres of construction. Now, one of the key metrics that we worked from was the programme that the contractor wanted to deliver the project. So ultimately, there's an end date the client needs the facility. So we're working back from that end date with the main contractor. And essentially, we're configuring a solution around that aspirational date. So this brought us to a 40-week programme to deliver the project, which means essentially we've got to construct around about 1,500 square metres per week. Most things that we've done has essentially been configured around that driver. So, defining the kit of parts, we need to take the buildings apart to put them back together again. So, the process we go through is we use an existing system that we've developed over the years. Some of that work's been done with Kia, some with other contractors, and the Ministry of Justice as a client. We need to take the functionality and the specification of the buildings, the programme as I mentioned, critically the logistics and the sequencing. Logistics and sequence is absolutely fundamental to offsite. We need to take some of the systems integration, which I'm going to describe, and some of my colleagues are going to describe in the later presentations. We need to take the assembly methodology, how we actually put this thing back together again. We need to take the manufacture methodology, how we make it away from the site. We need to look at the supply chain and its capacity and capability to deliver a project like this. And then we look at the design solution, and how we essentially dovetail the different design aspects together to give a coordinated solution. And all the time we're trying to balance cost and value. What's probably key, and I think one of the things I hope you'll get over in the presentation, is John touched on it very briefly, we've got multiple suppliers across multiple specialisms, all working together away from site to bring this thing together as a kit of parts and to give it the smarts that the building actually needs. So this is just an overview of the house block. So there's typically 56 cells per wing, per level, with some miscellaneous support functions on one of the wings. So 3 wings are cells, 1 wing is a miscellaneous support function. The cells are based around a repetitious platform design, which I'll describe in a second. Those cells contain things like ensuite facilities. They have the power and the data requirements for the cells. Then obviously there's finishes and functionality within those cells as a secure environment. But some of the key aspects of that design solution centers around security, durability and maintainability because of the type of facility it is. It's just a brief overview of the platform. The platform represents about 60% of the house block. So 60% of each of those 7 house blocks is this accommodation module. There's only 4 types of cell, which means there's lots of repetition within this componentization, which means it's really, really important to get the design solution correct because we're replicating it many, many times over. But also key to that is the refinement of that design, because when you refine that design, the benefit amplifies across all of those cells as well. There's 6 key component types. So we have an external wall construction, which is a composite sandwich wall construction, which we pre-install the window system off-site. We have what is a special duct wall unit, which separates the cells, which is a bespoke unit to the prison system. We have some slabs, a mix of corridors and cell slabs. The cell slab I'll describe in a little bit more detail. We have some partition walls and we have some corridor walls. Critical to us is how these components are manufactured, which influences the finishes. Critical to that is also the way these components are handled. Much of our consideration is less about the permanent design and much more about the temporary design, or taking the units from the molds, handling the units, stacking the units, getting the units to site. We then need to look at the assembly. So my analogy is a little bit like the car industry. If anybody ever walks around the car production line, nobody's ever looking for components. The components are where they need them. That's logistics. And then when they take the component and put it into the car, they're not looking how to connect it into the car, it just connects into the car. That's smart connectivity. So much of our focus centers around the logistical aspects of getting these components where they need to be where we want them and when we want them, but also how they connect together, because that needs to be efficient. It needs to be safe, it needs to be effective, and it needs to perform in the way that these buildings need to perform. Key to this as well is that what I described before about the amplification of the benefits or the negatives. If we get something wrong, it replicates 1,600 times. If we get something right, it replicates 1,600 times. So for every minute we can save, every hour we can save, every little bit of reinforcement we can take out, all of these benefits amplify across what we're trying to deliver for the client. This just touches on the temporary aspect, as I mentioned. So the temporary restraint of these components is fundamentally key and has to be built into the design solution, but also the health and safety of our operatives who are assembling these buildings and any other operatives who are working on site around us. So just as much design input and effort goes into the temporary condition and the assembly methodology as the permanent condition. This is that cell slab that I described before. So within the cell slab, we essentially have 5 off-site suppliers coming together, integrating into one concrete floor slab. The floor slab contains underfloor heating, which is embedded within the slab to heat and cool the cells. We have shower drains and shower feeds for an ensuite area within the cell. We have the dished area within the ensuite area to take the finishes for that ensuite area. And then we factor all of those things into the way that the component's going to be manufactured and how these off-site specialists all bring these components together to integrate into that component. This just describes pictorially a little bit more about the systems integration. M&E is critical to the facility, and the fact that most of the M&E is embedded within the structure, so people can't tamper with it, who are within the structure is key. So you can see just some of the manufacturing processes that incorporate some of this feature in. We've got the underfloor heating in the cell slabs in the top left. We have the external wall construction with the windows cast in. We've got modular M&E being installed within the structure as part of the superstructure delivery solution. We've got secure door frames being cast within units. We've got some of the functionality in the riser wall, which is the center image in the bottom row of images. Lots of integration with how the cell is serviced and how the building is serviced within that unit. And then we have some of the package plant which goes into the buildings as well as we construct the superstructure. I touched on the logistics and the sequencing being key. A lot of work has gone in with Kia and the other specialists who are working with us around the site logistics and the off-site logistics, the sequence in which cranes move around the site, the way we get deliveries to and from cranes, the way we work with other contractors around the site, the way we work with the infrastructure around the site, which is ever changing. It's quite a challenging site in terms of topography and rainwater, so lots of that has to be considered, because essentially each of these buildings gets constructed in a 13-week period with 2 cranes. So this means we've got about 350 deliveries per block, which means we're taking about 5.5 deliveries per day per block, which we need to get to the crane with the right bits of kit underneath the crane to put into position. This means all of the off-site stuff has to work in tandem with each other to make sure that's within the components when they get built into the structure. So just to give this a bit of perspective, we've got 7 cranes on this project working across 3 different streams on the project. We've got circa 20 deliveries per day per stream, and we've got about 440 tonnes of concrete per day going into the project to be installed. So this is just over 2,000 tonnes per week of pre-manufactured components, structural components, with all of this smart technology within it being assembled into these buildings. This is why the overall sequence and the logistics is absolutely fundamentally key to us. Just some of the stats, these might get repeated again a little bit later. So we've got over 15,000 precast components. We've got over 1,600 cell doors, over 2,000 windows, nearly 20,000 conduits to cast into the concrete, underfloor heating mats over 2,000, 1,680 shower trays, the list goes on. Also fundamentally key to us is what people see at the end is the finished component, but within the finished component, we've got the smart integration which I talk about, we've also got the reinforcement. And fundamentally where things go wrong in our industry is when reinforcement doesn't fit with other components and essentially the 2 things don't mesh together. This is where BIM and digital has really transformed our industry and our business. So now we're modelling reinforcement in 3D, modelling that with the components. So essentially we can check that all of these things fit together before we want to place concrete in the units. This is just some of the units being stored off site. So you can see on the left there some of the units with the corridor units with the door frame set within them. The cactus units there, which are the specialist unit for the prison cell platform. Just some images of assembly. We typically construct somewhere between 12 and 16 components per day, with about 10 men per crane, so there's not a lot of manpower on site, but there's a lot of activity on site. And you can just see also there in the top right hand corner we did precast ground beams on this particular project as well, so we're starting straight from the tops of piles, trying to do as much in terms of DFMA and off-site as possible. Critical to getting this right is knowing where you are at any point in time in the process. So a lot of effort goes into monitoring and tracking the plan versus what we're actually doing. So we do lots of things in terms of our approach, in terms of tracking progress and comparing and contrasting actual through design, through manufacture and through construction. But Rebecca's also going to talk about some of the clever digital stuff that Kia have brought to this project that really helped us in terms of monitoring that real-time data and tracking the actual versus planned. Quality control is also a critical facet of what we're trying to manage and deliver. We need to ensure that we're monitoring the quality process at each stage of the design and manufacturing process. So we have off-site coordinators working with the supply chain and the wider supply chain who are supplying into our precast supply chain, monitoring and managing the quality of those components at each stage of the process, so that when it arrives on site, we know it meets the specification, it's been validated and verified, it can then be assembled. This is some of the information that we produce for the guys to assemble these components, and then we track every component that gets installed. So essentially what we're trying to create is, as my managing director would call it, like a birth certificate for each component. So each component has got all of its data about its quality process that it's gone through, and then all of this can be fed back into the BIM process and logged with that component as the asset management strategy for the client. And then just moving forward, always looking to improve. So just some of the things that we have used and are using to develop the platform system for Kia and for the client. So we've got past projects and the data that goes with those projects. We have the existing platform design, we have the Wellingborough design, we have some of the data we're capturing on the project which Rebecca will cover. We obviously have the BIM data which goes with the model, and then we're doing some work with the Construction Innovation Hub around platform design, which will also feed into developing and improving and enhancing this system. That's kind of me done. Okay, I'm going to hand over to Rebecca now, who's going to talk a little bit about digital.
Thanks, Simon. So as the guys have said, Wellingborough is really pushing the boundaries, both in terms of the scale of design for manufacture and assembly, platform design, and also digital advancement. And with that, we're really finding that digital tools are to a large extent the glue that helps us achieve some of our wider aspirations. But to achieve that, we need a client that's supportive of a digital drive. We need forward-thinking people. As Simon said, we need digitally enabled and committed supply chain. And so as part of that, then, as you can see from the image on the board, Wellingborough, as John outlined, is all about trying to find a facility that facilitates rehabilitation for those that will reside there. But actually, transformation doesn't just happen in operation, it's happening for us in part of the construction phase. So to date, for example, we've won Digital Training Initiative of the Year for a digital apprenticeship scheme that we pioneered as part of this project. Wellingborough is also the first Kia project that's got project-dedicated data analysts, which is a huge step forward for us. Our first challenge was then, how do we reflect and transfer everything in terms of our digital intent and aspirations into something tangible and deliverable, and that's something that can be understood by the many and not just a few. The concept that we came up with, and our digital lead is in the audience today, is then what we've referred to as our digital mission statement, a jazzy title for what in effect is a digital poster The idea of this is that we set the digital scene and explain the various parts of what our digital aspirations are. For example, what's the BIM documentation? Trying to take the language of employees' information requirements, asset information requirements, and make it understandable. What's our model breakdown? In other words, who's producing what and why? We're then also looking at what are the digital tools that we're using on this scheme, more of which I'll describe in just a moment. We also go through our digital workflows, including quite specifically to Wellingborough, our drone workflow. Also looking at our digital calendar to make sure that we're setting the right basis in terms of model federation and exchanges. At the heart of the document is then our digital action plan. This is breaking down each of the tasks, assigning them to individuals, determining which is a client requirement, which is a Kia requirement, and what's the benefit we expect to get of each. We've linked this action plan then to a Power BI dashboard where we can then self-evaluate each month to then give us a level of granularity in terms of our digital performance. So our aim at Wellingborough was very much to deliver beyond BIM level 2 and ensure secure data handling throughout each of the project life phases. So for example, from federating the models with multiple designers using these, to developing a digitally rich component library from which we can undertake our fabrication drawings, developing inventories for real-time asset management, and as Simon mentioned, managing progress and quality of off-site and on-site works, to eventually provide a data-rich handover to the client. And I guess the ultimate aim is to create a digital feedback loop by which we can make future prison construction more predictable. So starting with then the initial design phase, so as integrator for this scheme, Kia is responsible for managing a really diverse team. So to give you some idea of that scale, we have 6 design consultants and to date have had over 70 contributors to our project information model. It might not sound particularly sexy, but one of the important parts for this is then ensuring that we get standardisation of naming conventions. So actually looking in the common data environment and finding that we have uniform naming and using TIDUPs and MIDUPs have actually allowed us to then link this into dashboards again to ensure that we have more access to managing the progress of design. In fact, the MOJ have actually gone so far as to say that the stage 4 Kobe drop at Wellingborough is the best they've received out of 5,000 to date. So that digital management at scale can be seen with some of the statistics at the moment. So the project information model currently consists of 283 separate models. We've had 18.5 million components go through our Salubri rule sets to date, and we're aiming to achieve a data handover to the client that will consist of over 6 million pieces of data. Now when you look at a traditional asset handover to a client, probably circa 70% of the maintainable assets are within the MEP sphere. So actually one of our key challenges was ensuring that we had continuity of MEP modelling throughout. So at a very early stage we took the decision to use one organisation, BIMTech, to undertake all the MEP modelling from cradle to grave. All of this is with the aim of focusing on getting detailed design earlier to enable the manufacture of off-site components. So as Simon's articulated, a key challenge is then manufacturing at scale across numerous locations, and that requires really detailed production and quality management techniques. So as well as a team of off-site expediters from both Kia and PCE as specialist integrator, we also deployed Dalux software, which is field BIM technology. As can be seen from the image on the screen, we translated our component schedule, which was derived from the BIM model, into an off-site reporting tool. This meant that from inputting the data direct into Dalux at the factories, we were then able to visualise this using Power BI and in turn turn it into real-time data management. We could do this by supplier and by component. This allowed us to manage demand in a much more agile way and make more timely decisions. So for example, if we need to adjust on-site build sequence to flatten demand, should a production-specific components be delayed, we're able to do that. And equally to determine buffer stock levels to ensure the relationship between manufacture and install rates are sufficient. It also helped with providing resilience in the market supply by ensuring accessibility to alternative sources. We're now, as we move on to on-site delivery, translating this approach by undertaking on-site quality checks using Dalux via smartphones. So this, when it achieves a Kia sign-off, it then sends an automatic link to our planning software to then automatically update our as-built programme. So this video, as you can see, whilst looks fairly simple in type, actually shows how we're linking quality and programme in it digitally and how we're applying 4D to Wellingborough. So again, we take the schedule information provided by PCE and push that back into the model via Dynamo. We can then provide further details, such as Simon was mentioning in terms of wagon loads, craneage information, and then we can auto-match that into our planning software. The result of that is that we know where each precast delivery is at any time and that we can react to changes in the programme as they occur. We're now extending this methodology beyond the precast panels to other aspects of the build and also trialling HoloLens to help with visualising programme, which is particularly of help when we're discussing it with the client. As you can see from the video behind me, the other part of digital tools that we're using on site is drone technology. So the Wellingborough site is circa 11.5 hectares and has a 20-metre slope, so there's a significant muck shift. As you can imagine, being able to closely monitor that cut and fill was really, really important to us. But as to was safety, and actually traversing a site of this scale with traditional surveyors would have taken a couple of days, so you'd never have got a true picture because of the rate of wagons going out the door. This actually meant that using drone technology for that surveys provided greater efficiencies to us, as well as taking operatives out of a dig area and away from big machinery. How did we do that? So drone tech would come to site and would, I guess in simple terms, fly the drone, take a number of photos to overlay to get a 3D model of the site. We would then tie that into known ground control points to really tighten up the survey and provide a point cloud. We could then take that to compare it to our formation levels for the new prison and therefore automatically generate our cut and fill report. This had massive benefit and is something that we're now looking at taking that drone technology further forward in terms of how we use that to monitor progress as we progress. Hopefully that gives you a bit of a snapshot of some of the digital tools that we've been using on site in Wellingborough. Now hand over to Simon that will discuss a little bit more about that digital use in the off-site manufacturing facilities.
Afternoon everybody. I'm going to take you on a little journey on where we came with doors and windows for the Wellingborough project, which were central to the delivery of the project. So we look at the start. There was a vision that the MOJ had, which was to have a window that had no bars in it. Conventional prison windows, vertical bars, stop the prisoners getting out, but very Dickensian in their look. It was also important that the cell door was compliant with the current building regulations from a thermal efficiency point of view. Ultimately, it's a prison window. It had to be secure. It had to have good ventilation, and obviously Kia and the MOJ are looking for good value for money as well, so it had to be cost effective. And we knew from day one that the construction methods would be precast, so we'd be absolutely on the critical path from day one. So we designed a new window. We took the bars out of it. We used SolidWorks, which is our 3D modelling tool. That gives the advantage of being able to share the model both with the client and also with our supply chain partners. Once we've designed the model and proven it, we had to go through testing. As you can imagine, on a prison, taking bars out the windows that have been there for decades is a big step. The MOJ were very, very nervous about it. We had to test the product and test it thoroughly to their approval and to their standards. So the first one you see on the screen was one that went wrong. It got very close, but wasn't quite good enough. We managed to get a hole in it big enough to get a prisoner out. Not deterred, a month later we started again. And same window, but a different glazing system. It passed the test that the MOJ placed on us, and it got signed off for use on this and future projects. We also looked at doors. The prison uses steel doors. Traditionally, those steel doors have been a welded construction. They didn't look very good. There was lots of witness marks where the welds were. They looked very industrial. We use bonding processes, rather like they use in aircraft manufacture now for the bonding of two metals. It's far more efficient and practical than welding. It looks a lot better, but it's also, more importantly, very, very robust and resilient. And again, new technologies had to be tested. And then finally, on the NPI process, every cell door in a prison has a little plug in it, which is used should there be a fire in the cell. That allows the staff to deal with the fire without necessarily having to open the door. These devices are known to block, which is a problem for health and safety, so we designed a new product which was, given that we were looking at a new door completely, seemed the right time to do it, and went through the approval process with the MOJ. Engagement was very important for us at the early part of this project. Kiers, it's fair to say, came to us. They looked at our technical capability, which was attractive to them. They saw that we had efficient factories, we knew how to make things efficiently and to the volumes that were required. We had BIM and digital capability. And what that enabled us to do on all parties really, Kier, the MOJ, Mace as well, was to actually work in an open workshop environment, and lots of trust was built up, lots of open discussion, and that really drove the project forward. Okay, so once we'd got a contract with Kiers, everybody's happy, so we had to now deliver the project and deliver it better. The tough challenge straight away for us was that the windows that we were looking to supply were a new product. We didn't have a factory to build them in or a production line, so we had to create that from scratch. And ultimately the beat rate that we had to supply into the precast yards was 80 windows a week. Doesn't sound like these windows are pretty big units. So we created a dedicated production line, we mapped the process, we bring in lean process and lean efficiency. We need to make them efficiently and eliminate waste in the manufacturing process. We had suppliers, we had to make sure that supply chain was managed. We had 4 of our individual sites manufacturing components, bringing it all together in the main factory in Wolverhampton. Kiers were very clear from day one that we had to have absolutely crystal clear quality plans that we were working to and adhering to, so sign off at every step of the stage. And then we had to develop an entire process, get the staff on board, create a production line, and commence delivery within 8 weeks from the contract signing. All tough to do, and so far so good. We're delivering on time, keeping the yards busy, which is good, and keeping the site fed with components. I mentioned about the doors earlier. Each of the red dots you see there used to represent a weld on a traditional door. A lot of welding. We took nearly 70% of that out by using bonding processes rather than welding. It's faster, it's cleaner, it's a better job. We also looked at how we produced the door frames. Door frames are on the critical path, they're all precast in the yards. Doors were cast at the rate of 60 units per week, and we were feeding multiple precast yards. So to do that, we looked at the sheer number of components we had and said, look, we're not going to do this all in-house, let's engage with the supply chain and get pre-cut components coming in the order that we need them to feed our production. Second area we looked at was automation. Traditionally, doors have been made entirely by hand. We said this is crazy, there's efficiencies to be had, the doors are all very much the same. We should be putting robotic equipment in. So we put a robot into our plant in Lisbon. We also put a robot into our plant in Bedford where the window frames are produced. Rebecca mentioned about driving skills forward. One of the guys that did the programming and development of this robotic cell was actually one of our third-year apprentices. So it's his first big project, and that's delivering very, very efficient and good productivity for us. So a quick update on the delivery plan. Well, we started in July. We've finished the windows actually this week, which is good. So all the precast yards will have all the windows that they need. Doors slightly behind in terms of the plan on doors because they come slightly later. So the door frames will all be done this month, and then door panels start to go in. We're actually installing those in the coming months. So a very good project, lots of challenges, and we just hope that we can keep this going with the planned build for new prisons that the government have committed to. Now over to Neil Appleton, so he'll do a closing statement.
Right, well thanks for the kind introduction, and crikey, what a fascinating project. Proper integration of modern technologies right across the supply chain. I work in Catapult world, and we see these technologies and we live and breathe this, but this is a real project that's pulled all this together. It's phenomenal. This is the future, I think you'll agree. So I'm going to deviate slightly from what we've heard about. As far as I know, there were no fibre reinforced polymer composites used on Wellingborough Prison. I work at the NCC, part of the HVM Catapult. We're down there in Bristol. 7 centres, we all work collaboratively. You'll know certainly MTC, who've got a bit of a presence here, and some of the other names you'll recognise. The HVMC, the centres, we all are government funded. And we take the fantastic innovations and inventions coming out of academia and factories and people sheds that are a proof of concept and help them de-risk and get through the industrialisation process so that the UK can take advantage of them. At the NCC, we specialise in predominantly fibre reinforced polymer composites. So this is materials like carbon fibre, glass fibre, Kevlar, and so on and so forth that you may have come across. We're quite sizable. There's about 300 engineers across our 2 sites in Bristol, and we operate in all of the sectors that use composites, whether it's 3,000 metres deep in the ocean or in space, and all points in between. I happen to work in construction. So when I was asked to do this session, I was asked to talk about what technology pulls, what interest are you seeing? And I thought, well, actually, I'll backwind to 2013 construction strategy. And just as a reminder, this was very, very salient, and we were actually kind of doing this. So we were looking at reduced costs, reduced carbon, faster delivery, productivity, and all of this good stuff is starting to happen. Perhaps not at the rate that government wanted, but it's happening. In relation to this, what do we see at NCC? And the pulls that I see off my client base are massively around sustainability at the moment, particularly around carbon footprint, circular economy. In fact, all of the themes that you'll see around here today are very, very true from all of the client base. We're also seeing a massive pull from our large infrastructure asset owner customers who want to maintain use of their assets in an assured, safe manner. Sweating the asset is the coin of phrase for that. But it's not just painting. We're seeing life extension of structures, conversion of offices to houses with different load duties, raising the height of existing structures. How do we repurpose? Whole life cost is a massive piece of agenda for a lot of customers, particularly around corrosion and the cost of corrosion. And we're seeing a massive pull as construction goes off-site. Off-site, as we know, embraces productivity, quality, assurance, and integration of technologies, but it comes with issues around thermal bridging potentially. So, where do composites fit in around this? Durability is one of the key elements. The typical materials we're working with, you'd recognise them as the materials you build boats from. So they're eminently resistant to water, that's why we make boats from them, and they don't corrode. So no galvanic corrosion. They are low weight, they can be incredibly lightweight. There's a reason you use them in space satellites. But in construction we use low weight, so that enables easy handling, reduced mechanical handling, reduced logistical costs, and it can reduce foundation loads accordingly. Conductivity is a fascinating one. Composites are a whole group of materials, and we can tune them to do what we want within certain parameters. So we can make them thermal insulators, we can make them thermal conductors, we can make them electrical isolators or electrical conductors. We can tune these things. That is an incredible, powerful technology. Carbon footprint, of course, is significant. The materials are generally a low carbon solution, but very much associated with bringing low carbon, sustainable construction. They offer a wide range of different form and finish, and I'll show some pictures later to elaborate on that. And of course, they're manufactured in a factory, often with highly integrated digital manufacturing techniques, so repeatable quality. But I quite often get the pushback. There's too much risk associated with them. On that illustration, the blue and the green are composites used in aircraft airframes. hopefully that starts to change the risk profile of new materials. So I'll go into talk a little bit about some examples, case studies that we can relate to. We're familiar with this issue, particularly around off-site modern methods of construction. How do you trim the insulation cavity? How do you support a door in an efficient manner that doesn't bleed all the heat outwards? We're familiar with steel, great material, but it's fairly conductive, 50 watts per meter K thermal transmittivity. Aluminium, 90. That's why saucepans are really good out of aluminium. They're fantastic for passing heat. Heat sinks, brilliant. Glass fiber composites, you're down to about 0.3. So graphically, I'm guessing people at the back probably can't even see the bar line there for FRP materials. What we came up with as a solution, and the surrounding structure is indicative, so it's not revealing too much of the client, is the cavity closure there, the sort of light green material. And you can see it's a structural component, highly precise, and very, very low passage of heat through it, meeting all of the client brief. And as an aside, a lower technology, or a more mature technology rather, is if you're doing that, why not construct window frames in composite? Granted, perhaps not for Wellingborough Prison, where you've got naughty people who are going to try and kick it apart. Likewise, doors are very much doable in composites, and a lot of modern, high-quality doors are now composite. The presentation on Wellingborough majored on precast concrete, so I thought I'd better get some precast in there. This is about Domino sugar refinement in the States. This is an existing building that was reclad in precast concrete window frames. As you can see, they're typical precast concrete, very, very fine finish, sharp arises, and I can tell you there was a lot of repeat modules, but equally a lot of short-run modules. The tools for this were created in composite. They were additive manufactured using a carbon-reinforced polypropylene. So that is plastic reinforced with very short fibre. When I started looking at additive manufacture, the machines was kind of this size, and you thought, yeah, it's great if you want a steering wheel, but it's not got a place in construction yet. You can now additive manufacture, well, I think the recent demo I saw was a powerboat, so it's getting bigger and bigger. And of course, that is a digital process, so you're taking the CAD model, the BIM model, digitally manufacturing the tooling, so you've got that nice golden thread through the process and assured product geometry. Also, the material self-releases, which I understand is fairly important in precast concrete and quite useful. The tools also didn't deteriorate, so there was no rework on the tools and no rework on product as the tools got older. And at the end of life, you grind the tools up and you put them back in and you make more tools. Around reinforced concrete, composites have a place to play. This is Thompson's Road Bridge, full HA loading in Northern Ireland. And that was reinforced with this stuff. This is basalt fibre composite rebar. And that's a bit of A393 fabric with my friend Yuri, just showing how light it is. There isn't a sky hook out of frame on that. The beauty of it is it's a non-corroding rebar. It's also lighter weight and easier to handle. The rest of the world's embracing this ahead of the UK. Eurocode 2 is going to address a non-metallic rebar, which is out within about 18 months, I believe. So this is going to become widespread in UK. I suggest you keep a definite eye on this. In Saudi Arabia, Saudi Aramco now mandate non-metallic rebar, i.e. composite rebar, for all of their groundworks because of the cost of corrosion. They've recently constructed a drainage channel for the Jazan economic city. That was a drainage channel that was 21 kilometres long. It had 11,000 kilometres of rebar. This is not a demonstrator, this is real world. This is happening. Interestingly, on that project, and the rebar was selected for corrosion, they won a 30% productivity gain by using these easier to handle lightweight materials. So, reduced maintenance through corrosion, Potentially you can start looking at reducing cement content. Do you need such a high cement content if your rebar cannot corrode? Following that example through, a little bit of the future vision of concrete. This is in Australia at Brisbane by Wagner's, a concrete company. And it's this unloading wharf here. The substructure was composite structures, but that's not the exciting part. The deck's the exciting part. That was geopolymer, so no ordinary Portland cement used within that concrete formulation. It was all alkaline activated fly ash. Reinforced with composite rebar, so no concerns about the durability, bringing these maintenance benefits again, and a productivity benefit into the bargain. Taking it further, there's some exciting work going on so we can make concrete perform better. This is next generation structures. This is in the States. This is a concrete arch bridge. For those of you who studied civils, you might remember that if you can constrain concrete, axially, you enhance the compressive strength. Research is showing between 6 to 8-fold improvements in compressive. So you take a C50 mix and you're getting something like a C300, C400 equivalent by having this constraint around the outside. You can make a much more efficient structure, reduce concrete, reduce carbon, faster, leaner, more efficient. Illustration of it going together. I would say this is demonstrating the high productivity, but as with all things, there's a crowd of onlookers at the back watching it going together. But you can see less temporary works, more efficient use of the concrete, so reduced carbon footprint, better productivity. There's a whole lot of work going on around new forms of concrete and using both metals and composites within them to exploit different properties. I'd recommend anyone to look at the Acorn project out of Bath or the work coming out of Queensland. Life extension, talked about sweating the asset. This is a bit from my past. This isn't a building, this is called an oil rig. These corrode like merry hell, and they repair the corrosion by bonding on composites. That is restoring the strength of corroded structure with composites. All of these elements I've been involved in rehabilitating. And some of these, like process piping, I've worked on 50 bar, 20-inch gas pipe. The caissons down at the bottom, they're typically meter diameter, and you can kind of see they're getting a bit of a push off the ocean there. And I set the scene earlier, form and finish. What can we do with composites that's a bit different? Again, drawing on the rest of the world for some great examples. This is Museum of the Future. This is a composite clad structure. This is Haramain Station in Saudi Arabia. The roof of this is composite materials, enabling a beautiful structural form. And closer to home, it's actually bigger than the photo makes it look. This is at Saltash, and this is the Celtic Cross. This is wholly composite, no coppersmiths involved in the construction of that. It's all in the material. So that concludes my spiel. We'll now go into a panel session. If my fellow speakers would like to take up a hot seat, do we have a roving mic as well? So, just to seed the first question to the panel to get the juices flowing and so on. Phenomenal project and brilliant integration, but how did the customer react to the level of innovation and risk that goes with it that you were bringing? And were they happy to embrace more basic, lower TRL innovations? Over to the floor, John.
They're very keen to innovate, but technical readiness is really important in that they've got an asset that needs to be maintained. Needs to be maintained and usable through its life. And so technical readiness, that's why we went through so many testing processes in things like the windows.
John, do you want to use the...
Testing.
Got a good one. Start again, please, John.
Supply chain helping me out again. Technical readiness was really important to our client, and whilst they wanted to innovate and ensure that we're moving forward, it had to be deliverable and operable for its life. So there's no value in having a prison that they couldn't then use. So we used the TRL process to ensure that all the products were ready for mass manufacture.
Thank you. And do we have a question off the floor, please? Oh, hold on for the mic. Thank you, sir.
In terms of clients, I've had experience of handing over BIM model information over to clients to see it stacked away into the archive room in a CD disk. Is your client ready to use this in an intelligent way to manage their asset?
We certainly, is this working? Yeah, we certainly hope so, and I think we're spending a lot of time now actually doing the educating part, so actually looking at what's their CAFM system going to be in terms of those that will be maintaining the buildings, actually spending a lot of the focus on the maintainable assets, so a large part is making sure we've got that training of end users taking place, you know, before we've even got structures in the ground, because it's a long process in terms of that soft landing to hand over.
Okay. Do you have a further question off the floor? Gentleman there.
It's actually for the chair. Possibly the most famous composite material, especially around residential, is SIP panels, structurally insulated panels. I was wondering what was the innovation around that? If you've been working with this material, what's the next? You mentioned geopolymers. Could it be something that will be adopted?
Yeah, we've done some exploratory work around constructional panel SIPs using composite materials, both the sort of traditional palette that I talked about, which tend to be fiber reinforced polymers, but equally using sort of natural fibers, bio, and a whole ruck of other materials. Ultimately, interest is limited at the moment. Post Grenfell, there's huge awareness of fire resistance, and a lot of the polymer composite materials, whilst they will meet Class B, they will not meet a Class A1. Hence, the drive away from great materials, even like CLT, in favour of steel, mineral board, rock wool. In terms of will the materials work, absolutely, and they bring some huge benefits, particularly around the thermal piece.
The tie system that we use on our composite wall system is a nylon material, so there's no metallic ties bridging between the two layers of concrete for that very reason. And I think these have been tested in excess of 4 hours and still don't burn, so it's quite an efficient way of forming an outer envelope with no thermal bridging.
Okay. Do we have another question off the floor? Thank you.
Hi, my name's Rachel Hayden. I'm a civil engineering student at the University of Bath. I just had a question regarding having so many different manufacturing subcontractors. How have they been digitally trained, to be able to contribute to the new software that you've produced, or has it been hard to get them on board?
I wouldn't say they've been retrained. We're taking existing technology and methodologies and applying them to a platform approach for this particular building type. Sorry, I misheard the question. The digital training, sorry.
Yeah, in terms of digital training, obviously you've produced this new digital platform, but how easy is it for them to have been, to be using it, to be able to contribute to that?
I think the answer to that question comes twofold. One is lots of different manufacturers work in different ways and have different systems and different levels of capability in terms of digital. So it's quite important for us to align that capability. So we control the design aspect of what we're delivering. So essentially then all we're dealing with then is the real-time tracking and data analysis of what we're actually producing and when we're producing it. The Daylock system that Keir have introduced on this project has been fantastic for that. So the guys who are working in the factories are working with smartphones linked straight back to the main BIM model. So essentially you're almost de-skilling a little bit the digital aspect, because they don't need to be so far advanced, because we're controlling the manufacturing and we're controlling the tracking. I guess perhaps from the manufacturing of the windows and the doors, which is a little bit more sophisticated in all fairness in terms of process, there's probably some upskilling and training and development, I think.
Yeah, we, I suppose as a business, because we're ultimately an engineering business, we've been using digital design tools, whether it's CAD or CAM, for many years. So it's just, we continue to reinvest in the people and new systems, and as they become a requirement, really. The bigger one for us is making sure that our systems are aligned with the client's systems, that we're not doing things in a standalone way.
One of the things I do like about the real-time data capture is you wouldn't believe the amount of paper that the industry creates for tracking and monitoring things. And it's like an eye-opener to use some of these systems and work in collaboration to get a better outcome. And a lot of the time you start with a little bit of pushback, because these are our systems, we're used to working with our systems. It doesn't take long for people to realise it's a lot easier, a lot more efficient, a lot cleverer not to keep producing these pieces of paper that nobody ever looks at again.
That's a really good point. I mean, we touched on lean and lean efficiencies in everything we do, and having effective data handling, so you minimise the amount of paper floating around, is absolutely central to that. It's not just about how we run our factories, it's how we run our offices and our site teams as well.
Yeah, so it sounds to me like in our normal way of life, we're used to using this for our shopping and managing our lives and so on, that technology is now seamlessly, well, painfully translated into mainstream construction. Is that a fair synopsis? You're talking about smartphones and gadgets that we're used to.
Yeah, I think that's absolutely right, because I think if it's not idiot-proof, and the idea if it hasn't got that end-user interface that we can all use it easily, there won't be the uptake, because you can mandate anything in a contract, but actually that's not how it's going to take off from the ground. It's about actually it's easy to use, and then if the doing of it, actually that will win people over, and then we'll get the momentum going. So it's really important that we work on that easy to use part of any digital tool.
Yeah, and sort of around that innovation piece and bringing things on board, were there lessons learned that you would take away from this and embody in the next prison project or next similar project? If you could elaborate.
Yeah, I mean, I think it's fair to say that so we often refer to the movement in terms of off-site, etc., is more about evolution, not revolution. So actually that journey's already started. So Simon made reference to HMP Oakwood, a prison that Kia and PC worked together 2012 to complete, and so that evolution has gone way back from there in terms of actually how do we refine the components we use, make smarter decisions around material efficiency, etc. And then more and more, obviously, with the carbon agenda, it's then how do we look at operational efficiencies. John mentioned about the energy efficiency of these buildings is 70% that of the MOJ's retained estate, but then for us to look more and more at embodied carbon and how we can make efficiencies there is a key area for us.
Fantastic. More questions off the floor? Okay. I'll just wind up with a general question to each of the partners here. There's a lot of discussion around reducing waste in construction these days for better efficiency and better profitability as well. Could you add some insight in how waste was reduced through the processes you used?
So I think waste comes in many forms, and one of the things we're very passionate about is the platform design and reusable design, and just saving time and being able to, as Rebecca touched on, evolve a product to be more efficient rather than reinventing the product consistently. And with the 10,000 places, that gives the MOJ a great opportunity to carry on that progression with an ever-improving product.
I guess from my perspective, the simple answer is we only bring to site what we put into the buildings, rather than bringing a load of stuff you don't need for the building to actually allow you to build a building. That's how we reduce waste.
I guess as a manufacturer, it's all about process mapping for us, eliminating waste in the processes, but also just practical things like reusable handling equipment. We made toast racks for putting the windows in to transport them to site, which then returned to us. So we're not having wasted packaging and so on, which ultimately is a cost saving and it's more sustainable.
Fantastic, thank you. Any questions off the floor before we wind up? Good. I'm sure the speakers will be pleased to take questions one-to-one. Certainly I'm around to talk composites. This is what I do. So could you raise your hands to excellent speakers? Thank you.